Okay, so let's have a look at this. 2x minus 11 is equal to a half x plus k. So we want to sketch this, and it's going to be minus 11's down there. So that's going to be 11 over 2, and that would be 11 up there. And okay, we know that this has got two distinct solutions. And okay, so this line here is y equals 2x minus 11, and this line here is y equals minus 2x plus 11. So two solutions for this one. If you imagine, okay, a half x has got quite a steep gradient, minus 2 and 2. So half x plus k would come across, you know, it's going to look like this family of graphs here, isn't it? Where it's like a more gentle gradient. So we want to know where it's got two solutions. So it's like everywhere here it's going to have two solutions, and everywhere down here it's going to have no solutions, and here it's going to have one solution. So where's it going to have one solution? Where it crosses 11 over 2. So where would that, if that's 11 over 2 and it's got a gradient of a half, what would that value there be? So that distance there is 11 over 2. What's that distance there? Let's call that k. So we want the change in y over the change in x to be equal to a half, the gradient of a half. So times through by 2, k is equal to 11. That distance k times through, no hang on, times through by a half, isn't it? No. So that 2 is going to come up here, isn't it? Yeah, so if we divide through by 2, we're going to get a quarter down there. Okay, so k over 11 is equal to a quarter, and k is equal to 11 over 4. Well, that's that distance, so you can see from the sketch it's minus 11 over 4. So this is minus 11 over 4. So it's when k is bigger than minus 11 over 4. When it's bigger than that, you're going to get two solutions. It's going to be this family here with two solutions here. So k is bigger than minus 11 over 4. Function is defined. Okay, sketch the graph fx between. Let's go this. Okay, so for x is less than 1, we've got minus x. So 1, we've got minus x, like that, and we want to sketch it in the domain from minus 2. So what's this value here? It's going to be 2, isn't it? And x minus 2 for x is bigger than 1. So x minus 2 for x. So 1, 2, x minus 2. For x bigger than 1, so it's going to be that. So there's going to be this jump, it looks like. X minus 2 is less than 1, and then you put a little circle here because it doesn't actually touch there, but that's solid, and that's a little open circle it's meant to be. Okay, find the values of x for which f of x, oh, and this goes up to 6, so we should put find that value of y as well. So if we've got f of x equals x minus 2, f of 6 is equal to 6 minus 2, which is equal to 4. So that value there, it's not very clear, is it? So if that's 6, then that's going to be 4 there. Okay, fine, that's A. And then B, find the values of x for which f of x is equal to minus a half. So minus a half, it looks like down here, which is this part of the graph, which is y equals x minus 2. So we want to put minus a half is equal to x minus 2. X is equal to 3 over 2. Does that make sense? That could be 3 over 2. Makes sense with the picture. Okay. Right. And let's have a look at 3. Okay, we've got some more functions to find. F of x and g of x. Right, so we've got f of x, well, written in a slightly different way as x over x minus 2. We want to find f minus 1 of x, so y is equal to x over x minus 2. Swap x and y, so we're going to get x is equal to y over y minus 2. So we're going to get x, y minus 2 is equal to y. We want to make y the subject again. X, y minus 2x is equal to y. Bring all the y's to one side. X, y minus y is equal to 2x. Y, x minus 1 is equal to 2x. And then y is equal to 2x over x minus 1. There you go. Write down the range. Ooh, what is the range of that function? I'm going to sketch it. What does that look like? Okay, well, maybe I'm just thinking it's one marker. Not straightforward how to sketch it, but the range of f minus 1 of x is equal to the domain of f of x, isn't it? So range of f minus 1 of x is equal to is f minus 1 of x exists in the real numbers, because that's the domain of f of x. Calculate g of f of 1.5. Okay, well let's so that's C, that's B. Let's see if we can get it all on one piece of paper. F of 1.5 is equal to 1.5 over 1.5 minus 2, which is 1.5 divided by, let's do it in fractions, 3 over 2 divided by minus a half, which is minus 3, is it? Yep. So g of f of 1.5 is equal to g of minus 3, which is equal to 3 over minus 3, which is equal to minus 1. Use algebra to find the values of x for which f of x, so g of x is equal to f of x plus 4. So let's do that up here. So this is 3D. So we want g of x is equal to f of x plus 4. 3 over x is equal to x over x minus 2 plus 4. So I'm going to write that as 4x minus 2 over x minus 2. And then bring this together as one fraction. 3 over x is equal to, that's going to be 4x minus 8 on the numerator plus x, so that's going to be 5x minus 8 over x minus 2. Then I'm going to cross multiply. 3x minus 2 is equal to x, 5x minus 8. And then expand. 3x minus 6 is equal to 5x squared minus 8x. Bring everything over to one side. I'm going to bring everything over to this side, so I've got a positive quadratic. 5x squared minus 11x plus 6 is equal to 0. Does that factorise nicely? 5x, that's prime, isn't it? X, 2 and a 3, no, 3 and a 2, no, 6 and a 1, yes, 6 and a 1, minus and a minus, so we get x is equal to 6 over 5 and 1. Okay, I've just gone and checked my answers. There's one little thing to look at that I've overlooked here. We can't have x equal 1 is a real problem. We can't divide by 0, right? So we need to include that into the range. The range. What's the domain? Hang on. What's the domain of f of x? X doesn't equal to 2. So yeah, we need to include that into the domain there, into the range.